All right. Good morning. Um, Again, we've been working with domain and asymptotes of rational expressions and left off most recently with polynomial inequalities, and we'll get further into that in just a moment. But just something I do want to mention. If you're looking at say in the realm of determining domain and asymptotes, okay, there was one problem I had run across in Alex, and just kind of providing one that is similar in nature. And say if you have a rational function, say we have in the form of where we have 4x squared plus 10x plus 1, and we have all over 2x plus 1. Okay, so for what we have here, okay, so if we're looking for the domain, okay, again, for a rational expression, the domain cannot be equal, the denominator cannot be equal to 0. Okay, so you have that 2x plus 1 cannot be 0. And looking at isolating the variable term, okay, so we have that 2x cannot be negative 1. And with division by 2, okay, so we have that x cannot be equal to negative 1/2. And so we have in the case of the domain, okay, if there's to be a term in x, it's going to be one of two things. Either it's going to be a value less than negative 1/2, or it will be a value greater than negative 1/2. So we have an interval notation. Okay, so you have parentheses around negative infinity and negative 1/2. And we have in union with the other half, and this will be symbolized by parentheses enclosing around negative 1/2 and positive infinity. Now for this particular rational expression, okay, now this is already in simplest form. So that means that 2x plus 1 is not going to cancel out. And with this factor still remaining in the denominator, okay, this will mean that this exclusion from the domain is going to be the vertical asymptote. Okay, so we have a vertical asymptote at x is equal to minus 1/2. And for what we have regarding any other asymptote, and again, this will come down to the comparison of degrees between the numerator and denominator. Once again, we have in the numerator, the highest degree term is at 4x squared. Okay, so we have a second degree, and in the denominator, okay, the higher order term is 2x, and that is first degree in x. And we have n at 2 and m at 1, and we're going to have the numerator degree to be higher than that which is in the denominator, okay, by 1. Okay, so this means that if the difference is 1, whereupon the numerator is greater in degree than what is in the denominator, okay, this means that there will be a slant asymptote and for the attainment of this, okay, so we're looking at polynomial division. Okay, so you have 2x plus 1 into 4x squared plus 10x plus 1. Okay, and I've been stressing the degree of the divisor. Okay, and if you notice, we have a linear expression, okay, with 2x plus 1. So x is a first order, but there is a little bit of a change dynamics, so to speak. We do have a linear expression in the divisor, okay, but we've had the general expression to be x minus c, okay, where there was nothing in front of the x, but if you notice, we have, for this linear divisor, we have the coefficient 2 out at the front. Now, technically, you could still perform synthetic division, but it will require an extra step of having to take half of everything in both the divisor and dividend. Like that would have to be lowered to x plus 1/2, and this part would have to be lowered to 2x squared plus 5x plus 1/2 just to maintain the proportion. Okay, so we got here. So we have, in the case of the polynomial division, okay, so I'm just going to, okay, in case you missed something, I had the full display of what I put up so far. Okay, so we have 2x plus 1, and we have taking into the dividend. Okay, so we have, in this case, right, so we have 4x squared plus 10x plus 1 okay, so we do not have any missing degree terms in the dividend. Okay, so we have, okay, so just in the lead off, okay, so we have, so you got 2x into 4x squared will go 2x times, and we have with distributing, okay, so you have 2x times 2x becomes 4x squared, and we have 2x times 1, okay, so that is going to be at 2x. And for what we have in lining things up, so we have like degree terms, okay, again, just vertically arranged. Okay, so we got, for taking the difference, okay, so you have 4x squared minus 4x squared, this will go out. Then we have 10x minus 2x, okay, so that's going to leave us with 8x. And then we can bring down the plus 1. And we have, in the case of the next portion, okay, so I took 2x into 4x squared, which went 2x times. And then after the first round of the log division process, now I have 2x into 8x, which will go 4 times. And distributing 4 over 2x plus 1, so I have 8x plus 4. And taking the difference, so we have 8x minus 8x goes out, and we have 1 minus 4, okay, so we're going to have it negative 3, and I cannot take 2x directly into negative 3, so negative 3 would be the remainder, and then we have for the item of interest, okay, and that is going to be the quotient itself, so that is going to be at 2x plus 4. So the slant asymptote will be y is equal to the resulting quotient, which in this case will be at 2x plus 4. Okay, and then just providing a graph, okay, where we have the asymptotes as well as the appearance of the graph of the function itself. Okay, so we have, again, for the rational function, I have 4x squared plus 10x plus 1 over 2x plus 1, and this will be the curves that appear in red. And with the vertical asymptote, we have x equal to negative 1/2, and this is this blue line, okay, that is running up and down. And again, vertical asymptotes will always be off limits. And for what we have in the case of the slant asymptote, okay, this is the green line that is running diagonally. Now, given just the right function, okay, now again, a function can come into contact with a slant asymptote as well as a horizontal asymptote. But for this particular rational function, it looks like that one is just going to be running tangent and not coming into contact either. So this is another case of what we have for function, okay, that will consist of asymptotes, one vertical and the other one which happens to be a slant asymptote. All right, now for what we have in the case of polynomial inequalities, and we have just for continuing on with those items. Okay, so we have just as a case here, now a lot of the problems in the examples, okay, will involve comparison to zero. But I'm just going to go kind of give a little different setup on this one. Okay, say if you're looking at solving for x. And in the case of solving for x, okay, say we have, first of all, we can say we have an equation whereupon we have x squared plus 6x is equal to 16. And then starting out with inequalities, okay, so I'm just going to still work with x squared, 6x, as well as 16, so we have less than 16. And we have x squared plus 6x is less than or equal to 16. And we have x squared plus 6x is greater than 16. And we have x squared plus 6x is greater than or equal to 16. Okay, now I'm going to solve the equation and establish those values of x which we used as zeros in the table setup that will enable us to solve for each of these inequalities. Okay, so we have at the start, so we have x squared plus 6x is equal to 16. Now we have a quadratic equation, okay, that is not in standard form. So if I write this in terms of where I have 0 on one side of the equation, so what I can do here is take away 16 from both sides. So we have in the rewrite, okay, so we have x squared plus 6x minus 16 is equal to 0. And looking at factoring, okay, so x squared goes to x and x. Factors of negative 16 whose sum or difference will be on the plus side at 6. So in this case we have more weight is going to be given to the addition than to the subtraction. So we have x plus 8 and x minus 2. And utilizing the zero product property. Okay, so I have x equal to negative 8, as well as x is equal to 2. Okay, so those will be our two solutions in x. Okay, now for the backdrop in terms of setting up a table, okay, whereupon I can take the or create a pathway to solving for these inequalities. Okay, now we had x squared plus 6x is equal to 16, and I'm going to establish a function, and it'll be that which I had arranged and was able to convert as a statement set equal to 0. Okay, and so we'll say that for that which is equal to 0, this will be our f of x to deal with. Okay, so I have f of x is equal to x squared plus 6x minus 16. Now again, we have the zeros. Those are the solutions we had in x, okay, which we had at minus 8 and positive 2. Okay, so this is what we have so far. So I solved for x squared plus 6x is equal to 16, and I set equal to 0. So this trinomial, this will be our f of x that we're going to be working with in the table setup. And again, we have the zeros at negative 8 and 2. Okay, so we have with the intervals. Okay, so we have kind of dancing around the zeros. Okay, so we have negative 8 is the smaller of the zeros. So the first interval section will be those values of x which will be less than negative 8. Then we have after this, okay, we have those values of x that will be greater than negative 8 and less than 2. And then we'll have those values of x which will be greater than 2. And again, we're going to partition these intervals. And first of all, okay, in terms of setting things up, okay, so I'm going to test each of these interval sections and kind of using as a bit of a probe. Okay, so we have with the tested value for the input. Now for test value x, okay, so we have, and you can arbitrarily choose numbers, okay, as long as the number you choose belongs to each of the sub-interval sections. Like you can choose, okay, here, whatever you choose, it could be negative 50, it could be negative 1,000,000, but I would recommend keeping the absolute value relatively low. So something that is less than negative 8, okay, negative 10 is a possible choice. And then we have, if I choose a value between negative 8 and 2, but not including negative 8 or 2, it could be negative 7, could be negative 5, could be 1, and also a popular choice, okay, is just the number 0. And then we have, for any number greater than 2, okay, we can go with the number 3. Okay, and I'm referring to like negative 10, 0, and 3 as selected test values, okay. And the thing is, what am I testing? Well, it'll be this particular function, again, which is x squared plus 6x minus 16. Okay. All right, so you have f of x at x squared plus 6x minus 16. And again, this was attained from setting this equation equal to 0. So we have our variable expression, f of x at x squared plus 6x minus 16. Okay, so looking at taking what we have for f of negative 10 as well as f of 0 and f of 3. Okay, so I'll just go ahead with 0. We have 0 squared plus 6 times 0 is 0. Take away 16. So f of 0 is equal to negative 16. Okay, now for f of negative 10, okay, so just running it through the operations. So I have the square of negative 10 plus 6 times negative 10 minus 16. So the square of negative 10 is going to be 100. 6 times negative 10 is negative 60. We have minus 16, so 100 minus 60 is 40, minus 16, so that is going to leave 24. Now for f of 3, okay, so you have 3 squared plus 6 times 3 minus 16, so we have 3 squared is at 9. And we have 6 times 3 is 18. We're going to take away 16, so we have 9 plus 18 is 27 minus 16. Okay, so that will leave us with 11. Okay, and then we have just for the last row, okay, this is going to be dealing with the sign value of f of x. Okay, so whenever we tested anything from an input that is less than negative 8, the output is going to be positive. So here we're going to have the f of x is positive. Anything we select greater than negative 8 and less than 2, the output is going to be negative. Okay, like negative 16 being such a case whenever 0 was the input. So we have the f of x is less than 0. Then anything for the input we select that is greater than 2, your y value or your output is going to be positive. So again, we have the f of x is greater than 0. So in terms of sizing things up, so we had negative 8 and 2 as the solutions for the equation. Now, for what we have for the inequalities, okay, so again, had x squared plus 6x is less than 16. And again, just writing as a comparison to 0 inequality. Okay. So we have x squared plus 6x minus 16 is less than 0. If you notice, okay, rewriting this as a comparison to 0 inequality. Okay, so again, your f of x is represented by this trinomial. So if x squared plus 6x minus 16 is less than 0, okay, this will be along the lines of where we have f of x is less than 0. And so we're going to have for the solution, so looking at where f of x is less than 0, okay, so if you look at the top, okay, we have those values of x between negative 8 and 2, and we have the values encapsulated within parentheses. And for what we have in the case of the next item, in fact, I can mostly duplicate what I have here. And this time we have with x squared plus 6x is less than or equal to 16, and rewriting in comparison to 0. So I have x squared plus 6x minus 16 is less than or equal to 0. And this will be in line with where we have that f of x is less than or equal to 0. Okay. Now I'll just mention here for less than or equal to 0. So you have things going in the same direction. As f of x is less than 0. So you'll be looking at the same limits, but whether those upper and lower limits that are cited will be included or not, the equal sign is a little bit of an indicator. Now, again, so you have the same direction as f of x is less than 0. So you're looking at where f of x is less than 0. So you're looking at, again, looking at values between -8 and 2. Now, notice we had parentheses because we had f of x, or the nature of the inequality was less than. So with the less than, greater than statements, there are no brackets. But with the equal sign, -8 and 2 make the function equal to 0. So you got the same numbers, but you'll have different groupings. And because -8 and 2 create the equal to parts, okay, those values will be in brackets. And for what we have in the case of the next item, okay, so we're looking at whereupon we have x squared plus 6x is greater than 16. And so what I'm going to do here, let's go ahead and shrink this. Okay, so we have and again, we have changing directions. So where we have x squared plus 6x is greater than 16. And again, converting to a comparison to 0 inequality. So we're going to have x squared plus 6x minus 16 is greater than 0. Again, so again, f of x is x squared plus 6x minus 16. So we have f of x is greater than 0. And for what we have in the makeup of the solution, so looking at where f of x is greater than 0, so there'll be no brackets because you got the greater than, no equal sign included. So you got f of x is greater than 0 here. So the corresponding portion, okay, we have those values of x that will be less than -8. And also have f of x is greater than 0, and this will correspond to those values of x which will be greater than 2. And then we have for the last of the inequalities, okay, so for x squared plus 6x is greater than or equal to 16. And again, rewriting as a comparison to 0 inequality. Again, I have x squared plus 6x minus 16 is greater than or equal to 0. And again, this will be the same direction. as what we had with f of x is greater than 0. Okay. And this time, okay, we have with the equal sign included. Okay, it's going to turn out that we're going to be including those values that set x squared plus 6x minus 16 equal to 0. And again, those values will be negative 8 and 2. So we're still working with the same numbers, but the solution is inclusive of both negative 8 and 2. And so those items will be in the brackets. So again, if you have your statements be less than or greater than, your grouping symbols will be exclusively parentheses. But if you have the equal sign, there is the potential for there to be brackets. And again, infinities are boundless, so they stay in parentheses. All right, and now just looking at solving for inequalities, and I tell you what, let's say just for the next few moments. See what we get for the interval solution to just this single inequality, whereupon we're going to have x squared minus 4x is greater than or equal to 32. Okay, so for the next few minutes, okay, let's see what we get for the values of x such that x squared minus 4x is greater than or equal to 32. Okay, tell you what, just for the setup on this one, okay, so we're looking for the interval solution to x squared minus 4x is greater than or equal to 32. Okay, and just some things to mention. Okay, so okay, for x squared minus 4x, okay, is greater than or equal to 32. Okay, now if I were to rewrite what I have here as a comparison to 0 inequality, okay, so I have x squared minus 4x minus 32, okay, is greater than or equal to 0. Okay, and so this is, okay, so we're going to have our f of x to be greater than or equal to 0. Okay, and now looking at the zeros, okay, from which we're going to have the formation of the table of intervals to be centered around. Okay, so again, if I have x squared minus 4x minus 32 equal to 0, okay, is equal to 32. And if I set the equation equal to 0, so I have x squared minus 4x minus 32 is equal to 0. Okay, so looking at factoring, okay, so I have x squared, so I have x times x. Okay, and for factors of negative 32, okay, so we have a plus 4 and a minus 8. Okay, so I have x plus 4 is equal to 0, so we have x equal to negative 4. And for x minus 8 equal to 0, okay, so I have x is equal to 8. So again, just taking what we have again. So we have f of x. Again, we have x squared minus 4x minus 32. And for the zeros, okay, so you have negative 4 and 8. Okay, so if we're looking at establishing intervals, okay, so again, you have your zeros at negative 4 and 8. Okay, so we have in the setup, so we have those values of x between negative infinity and negative 4. Then we have those values of x between negative 4 and 8. And then we have those values of x which will be greater than 8. Okay, and so for what we'll have in terms of setting up the table, okay, so you have separate interval sections. So again, we're just having separating case, so just going row by row. Okay, so again, I have an interval, and again, we have test value inputs. And again, we have f of x equal to x squared minus 4x minus 32. And again, we're looking at the sign of f of x. Okay. And so just once again, just separating the intervals. Okay, so for what we have in the setup, so you can select for the respective test values. We have in the first case anything less than -4, we can just go with -5. And between -4 and 8, we can go with 0 again. And then anything greater than 8, we'll just go with the number 10 on this one. Okay, so we have with each of these inputs, so I can select -5 since that is less than -4. 0 is between -4 and 8, and then 10 is a value that is greater than 8. So we have here, okay, for f of -5, and f of 0, and for f of 10, okay, so I can just go ahead and tackle 0. So we have 0 minus 0 minus 32. Okay, so we have -32. For f of -5, okay, so plugging in -5 for x. Okay, so we have the square of -5 and I have -4 times -5 minus 32. Okay, so we have the square of -5 is going to be positive 25. We've got -4 times -5 is going to be positive 20. And so we got 45 minus 32. Okay, so the final output here, okay, we have at 13. And for f of 10, I'm just taking what we have now. Okay, so we have 10 squared minus 4 times 10 minus 32. So we have 10 squared is 100. And we got minus 40 minus 32. So 100 minus 40 is 60. Take away 32. Okay, so that is going to be a positive 28. And again, addressing the sign values of the output, okay, for each of the sub-interval sections. Okay, so for any input that is less than -4, okay, the output is going to be positive. And then we plug in greater than -4 but less than 8, the output is going to be negative. So we have the f of x is less than 0, and then anything we plug in for x greater than 8, like 10 being a sample, the output, like in the case of like 28 from the sample, okay, you're going to have to result as a positive. Again, so we're going to have the f of x is greater than 0. And so we're going to have here for x squared minus 4x is greater than or equal to 32. Again, this is going to be referencing where we have f of x is greater than or equal to 0. So this will be in the same direction as where we have f of x to be greater than 0. So in the case of the solution, okay, so you have the same direction. So the corresponding limits, okay, we have involving negative infinity, and -4, and also you have involving 8 and infinity. Okay, and in terms of closing out, again, infinities are boundless. Okay, so we maintain the use of parentheses. and then with the equal part equal to 0. Okay, so negative 4 and 8. Okay, set f of x equal to 0. So negative 4 and 8 are included, and again around those values will be brackets. And again, had the statement been greater than 0, or had we had the inequality to be greater than and not including the equal sign, we would have had the unanimous use of parentheses for the grouping symbols. All right, now just other cases that we have regarding inequalities, and just a little bit of refresher. And let's say that if we have, for instance, okay, say if we've got so we have x squared minus 6x is less than 0. So we already have a comparison to 0 inequality. So our f of x will be x squared minus 6x. And again, if we establish the zeros, so if I have x squared minus 6x is equal to 0, so looking at factoring, so if I have x times the quantity of x minus 6 equal to 0, so we have x equal to 0, and for x minus 6 equal to 0, so you're going to have the x is equal to 6. So again, we're going to have f of x equal to x squared minus 6x. And for the zeros, okay, so we're going to have it 0 and 6. And looking at establishing a table of intervals. Okay, so you have the zeros at 0 and 6. Okay, so starting at the lower end, you have those values of x less than 0. And then you have those values of x between 0 and 6. And then we'll have those values of x which will be greater than 6. Again, we have the cycle of putting in the test values for the inputs, and again testing out the function for each input. And again, we're looking at the sign of f of x. Okay, so for what we have here, for tested values x, okay, so anything less than 0 was going to be any negative value. Okay, so we'll just go with -1. If you choose -10, that's fine. Then we have anything between 0 and 6. We'll say the number 4. Anything greater than 6, we'll just go with 7. Okay. So again, we're looking at f of -1, f of 4, f of 7. Okay. So for negative 1, okay, so you have negative 1 squared. And we have minus 6 times negative 1. And the square of negative 1 is going to be a positive 1. Negative 6 times negative 1 is going to be a positive 6. And 1 plus 6 comes out to a positive 7. And for f of 4, so you have 4 squared. You have minus 6 times 4. 4 squared is 16. And 16 minus 24. Okay, so this will come out to a negative 8. Then we have for f of 7, okay, so you have 7 squared minus 6 times 7. 7 squared is 49. Negative 6 times 7 is negative 42. And 49 minus 42, okay, we have a positive difference at 7. Okay, so for the sign of f of x, so any input that is negative, the output is going to be positive. So you have f of x is greater than 0, and then for any input that is positive but less than 6, again, any input that is positive and less than 6, the output is going to be negative. So you're going to have the f of x is less than 0, and then for any input that is higher than 6, the output is going to be positive. And so again, we have for this inequality, okay, so we have for x squared minus 6x is less than 0. Again, this is going to refer to f of x is less than 0. So for your solution, it is just going to be this set of terms. Again, so that's going to be the values of x such that x is greater than 0 and less than 6. Again, no brackets in this one, thanks to the exclusion of the equal sign from the inequality. Okay, and let's say that if I have we have an inequality, and we'll say that we have x squared minus 3x is greater than or equal to 18. Okay, so if I reconfigure to where I'm going to have a comparison to 0 inequality, so what I can do here is I have x squared minus 3x minus 18 is greater than or equal to 0. So in functional terms, okay, we have f of x is greater than or equal to 0. And if I look for the zeros, okay, so I have that x squared minus 3x is equal to 18. Again, just setting this quadratic equation up as one that is in standard form. So we have x squared minus 3x minus 18 is equal to 0. And looking at factoring, okay, so I have the quantity of x plus 3 times that of x minus 6 is equal to 0. And again, we have with the zero product property. So we have x plus 3 is equal to 0 and x minus 6 is equal to 0, from which we're going to have x equal to negative 3 and x equal to 6. Okay, and so we have, in setting things up, Okay, so again, our f of x is going to be the formed trinomial that we had in arranging things where we have a comparison to zero statement and the inequality as well as the quadratic equation. So our f of x is going to be x squared minus 3x minus 18 and for the zeros, okay, so I have negative 3 and positive 6. And so we have for the interval sections, okay, so we have those values of x less than negative 3. And we have those values of x between negative 3 and 6. But not including negative 3 or 6. And then we have those values of x which will be greater than 6. And again, just re-entering the cycle. Okay, so again, you have your tested value inputs. And they'll be used, okay, in establishing, okay, just the nature of the output. And again, we have the sign of f of x. Okay, so we have in getting things squared away. Okay, so we have in the case of selecting test values, okay, for the input. Okay, so we have for the first category, okay, we have anything that is less than negative 3. Again, we're looking at more highly negative than negative 3, and negative 4 would be such a value. And we have between negative 3 and 6, but not including negative 3 or 6, so 0 is going to fall in between. And then anything greater than 6, we'll just go with the number 10 on this one. Okay, so we have with looking for the output, so we have f of negative 4, f of 0, and f of 10. Okay, so for f of 0, okay, so I have 0 minus 18. Okay, so I have f of 0 equal to negative 18. Now, for what we have for f of negative 4, okay, so we have the square of negative 4 minus 3 times negative 4 minus 18, so the square of negative 4. Okay, so that's going to be 16. Negative 3 times negative 4, okay, that'll be a positive 12. And I have minus 18. Okay, so 16 plus 12 is 28 minus 18. So we have for the output, okay, that is going to be a positive 10. And then we have for f of 10, okay, so I have 10 squared minus 3 times 10 minus 18, so 10 squared is 100. We got minus 30 minus 18, so 100 minus 30. Okay, so there'll be 70. 70 minus 18. This will come out to a positive 52. Okay, so for the sign of f of x, okay, so you have a positive, whereupon f of x is greater than 0. Then for the what we have in the middle, okay, so you have a negative, whereupon we have f of x is less than 0. And then for any input greater than 6, the output is going to be positive. So again, we have f of x is greater than 0. Okay, so for what we have in this case, right, so we have, again, starting out with x squared minus 3x is greater than or equal to 18. And again, just rewriting in terms of f of x. Okay, so you have f of x is greater than or equal to 0. And we're going to have, in the case of the solution, again, we have in the same direction as where f of x is greater than 0. So we're going to involve the limits from the first and the last interval subsections. Okay, so you have between negative infinity and negative 3. Okay, we have f of x to be greater than 0, and you have also, for those values, okay, between 6 and infinity. Okay, and again, in terms of closing out now, infinities are boundless, so we maintain the use of parentheses. And then since we got the equal sign, okay, that means that there can potentially be the insertion of brackets. And since negative 3 and 6 cause this statement to be equal to 0, that means that negative 3 and 6 are part of the solution, and so they will be in the brackets. All right. And let's say now, in the case of what we have with polynomial inequalities, and I tell you what, let's see what we get in solving for x. For the inequality, and we'll say that we have x squared minus 2x is less than or equal to 3. Okay, just for what we have for this inequality. So again, I'm going to set up a table and identify, before the table setup, okay, what will be the function f of x as what will be the zeros involved. Okay, so we have for this inequality, okay, so we have x squared minus 2x is less than or equal to 3. And if I rewrite what I have here as a comparison to 0 inequality, so I'm just going to take 3 away from both sides. So we have x squared minus 2x minus 3 is less than or equal to 0. Okay, so we have the f of x is less than or equal to 0. And just looking at what we have for x squared minus 2x is equal to 3. Okay, so looking at determining the zeros. Okay, so if I rewrite this equation, set equal to 0. So I have x squared minus 2x minus 3 is equal to 0. And looking at factoring, so we have an x squared. Okay, this will factor out to x and x. And factors of -3 whose sum or difference will be at -2. So we have x plus 1 and x minus 3 as the factors. And then just setting the factors equal to 0. So for x plus 1 equal to 0, so I have x equal to -1. And for x minus 3 equal to 0, okay, so we have x is equal to 3. And so we have f of x is equal to, once again, x squared minus 2x minus 3. And again, the function will be, after the conversion, okay, what is compared to 0 or equal to 0. So you have x squared minus 2x minus 3 is f of x. Again, we have with the zeros, okay, so you have -1 and positive 3. And again, just setting up the table. Okay, so we have for the interval sections. Okay, so the zeros, you have a -1 and 3. So you have those values of x less than -1. Then you have those values of x greater than -1 and less than 3. Then we have those values of x which will be greater than 3. Okay, and then looking at taking what we have for the tested values. Okay, so for anything less than -1, okay, we might go with -2, let's say. Anything between -1 and 3, if I go with integers, I can choose 0, 1, or 2. We'll just go with 0. Then anything greater than 3, we can go with, say, the number 5. Okay, so just looking at what we have and applying each of the tested values to our function. Okay, so you have f of x is equal to x squared minus 2x minus 3. Okay, so looking at f of -2, f of 0, and f of 5. Okay, so just going ahead and taking care of f of 0. So the variable terms will be negligible, and we have just the subtraction of 3 to follow. So we have f of 0 is equal to -3. Now for f of -2, okay, so we have square of -2. We have -2 times -2 minus 3. So -2 squared is 4. Negative 2 times negative 2 is a positive 4. You have minus 3. Okay, so 4 plus 4 is 8 minus 3. So for this output, okay, that's going to be a positive 5. Then we have for f of 5. Okay, so we got 5 squared minus 2 times 5 minus 3. So you have 5 squared is 25. Negative 2 times 5 is negative 10. We have minus 3, so we have 25 minus 10 is 15 minus 3. So we're going to end up on the plus side at 12. Okay. And so just rounding out, okay, so we have with the sign of f of x. Okay. So from the first, okay, we have a positive output. Okay, so we have f of x is greater than 0. Then for the next, we have a negative output. So we have f of x is less than 0. And then for the last, okay, the 12 indicates that we're going to have a positive output, okay, for any input that is greater than 3. So again, we have f of x is greater than 0. Okay, so again, this is the inequality we started with, and then converting, or in the rewrite, having this in comparison to 0. So this will be in line with f of x is less than or equal to 0. And for what we're going to have in the case of the solution. Okay, so less than or equal to 0 would be the same direction as f of x is less than 0. So you're looking at numerically, just looking at the limits. In this case, we have looking at both negative 1 and 3. Now, had I had the statement to be less than 3 from the get-go, the conversion would have been f of x is less than 0, and I would have had parentheses around negative 1 and 3. But with the inclusion of the equal sign, and since both negative 1 and 3 cause this expression to be equal to 0, that means that instead of parentheses, we're going to have brackets. So your solution will be brackets around negative 1 and positive 3.